In last class, we learned about what is reflexive relation, what is symmetric relation, what is transitive relation. These three are very important definitions in this exercise. This class, I am going to quickly revise what is reflexive relation, what is symmetric relation, what is transitive relation, and we will start doing exercise problems related to first exercise in Relations and Functions chapter. Reflexive relation. What is reflexive relation? A relation R on set A. First of all, R is a relation on set A. Is said to be reflexive relation if you take an element X in set A. If you take an element X in set A, ordered pair X comma X present in the given relation, then we call that relation is reflexive relation. What you need to remember, for any X belongs to A, order pair X comma X belongs to R, then we say R is reflexive relation. In last class, I explained clearly about this and we did few examples also. In case if you not watched that video, you cannot understand this class. Please check the last video first. Okay, so this is reflexive relation. Now, what is symmetric relation? A relation R on set A is said to be symmetric relation. First of all, R is a relation on set A. R is a relation on set A. That relation is said to be symmetric relation if for every order pair, in case if you take an order pair A comma B in the relation, the order pair B comma A also present in the relation, then we say that relation is symmetric relation. If order pair A comma B is present in the relation, then we will check order pair B comma A is present in the same relation or not. If order pair B comma A is present in that relation, then we say that relation is symmetric relation. These examples I discussed in last class. Please go through that video. Now, next, transitive relation. A relation R on set A is said to be transitive relation. First of all, R is a relation on set A. That relation is said to be transitive relation if order pair A comma B and order pair B comma C belongs to R. If you are able to identify two order pairs in the given relation, order pair A comma B and order pair B comma C are present in the relation, then order pair A comma C is present in the same relation or not, we will check. If order pair A comma C present in the same relation, then we say that that relation is transitive relation. In last class, I did 40 minutes video to explain reflexive symmetric transitive relation. Please watch that video first. This is just quickly revising what is reflexive relation, what is symmetric relation, what is transitive relation. Now, we will start exercise problems, first exercise problems in relations and functions. This is the first question in this first exercise. In this first question, like this, total 9 bits are there. So, if you understand all these 9 bits, it means that you understand reflexive, symmetric, transitive properties. To explain these 9 bits, it takes 2 classes. In this class, I am going to do 4 bits only. Whatever the point I'll explain, you listen all the points carefully. Otherwise, this is confusing one. No doubt in that. This checking reflexive relation, checking symmetric relation, checking transitive relation is definitely confusion will be there in this. Whatever the points I am saying, you please try to understand those things clearly. After completion of this class, you take pen paper, practice these things again, then only you can understand. You see what they are asking in this first question. Determine whether each of the following relations are reflexive, symmetric, transitive. They are asking you to check. They'll give one relation. You need to check that relation is reflexive relation, symmetric relation, transitive relation. You need to check all 3 properties. You know what is reflexive relation, you know what is symmetric relation, you know what is transitive relation. Okay. So, in first question, total 9 bits are there. In all 9 bits, what we are going to check? They'll give one relation. We will check whether it is reflexive or symmetric or transitive, that we are going to check. See this first bit. What they are saying, relation R in set A. Set A is given and they are saying R is a relation in the set A. R is a relation in the set A. Okay. What is set A? 1, 2, 3 like that up to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total 14 numbers are there. 14 elements are there in set A. How the relation is defined? The order pair X comma Y such that 3x minus Y equal to 0. See, they given one relation. They are saying R is a relation on set A and what is set A also specified. Okay, question will be given like this. Now what you need to check? You need to check this relation is reflexive relation, symmetric relation or transitive relation. All those three properties you need to check. See, this relation is in set builder form. I hope you memorized what is set builder form. All the elements are represented with its property. This relation is in set builder form. If this relation is in roster form, then we can easily check whether it is reflexive or symmetric or transitive, right? So I want to write this relation into roster method. What is roster method? All the elements are listed and separated by commas within brackets. I'm going to explain that. First thing here, this relation is in set builder form. Okay, in all these 9 bits, first 3 steps are going to be common. Common means same pattern. See, what is the first step? On what set the relation is defined? See, R is a relation on set A. They are saying that R is a relation on set A. Set A is what? They given set A 1, 2, 3, 4, 5, 6, 7, 8 like that up to 14. First step is what is the given set. Second step, this relation is from where to where? They given relation R in the set A. R is a relation on set A means R is a relation from A to A. Second point you need to understand, given relation is from where to where. That is important. Here R is a relation from A to A. Understand, R is a relation from A to A. That is the second step. In all 9 bits, first 3 steps like this only. What is the given set? And second one, relation is from where to where. Third one, what is the given relation? This is the given relation. Order pair x comma y says that 3x minus y equal to 0. In all 9 bits, first 3 steps will be like this only. What is the given set? R is a relation from where to where. How the relation is defined. Okay. After writing these 3 steps, to check reflexive property, to check symmetric property, to check transitive property, if you can write this relation in roster method. If you can write this relation in roster method, it is very easy to check. So here R is a relation from where to where? R is a relation from A to A. R is a relation from A to A. You understand, R is set of all order pairs from A to A. That means here X is in set A. What is X? X is in set A. What is Y? Y is also is in set A. If R is a relation from A to B, then X is present in set A, Y is present in set B. You just go through the definition of relation. What is the relation? Set of all, so Cartesian product definition. What is Cartesian product? Definition? Set of all ordered pairs from A and B. Here R is a relation from A to A means what is X? X is present in set A. What is Y? Y is present in set A. What point I am discussing now, that is very very important. Listen carefully. X is in set A. That means what X may be? X is in set A. That means you can take X1, you can take X2, you can take X3, you can take X4, you can take X6, you can take X7, you can take X13, you can take X14. Can you take X15? Can you take X15? No, you cannot take X as 15 because X is there in set A. What is Y? As relation is from A to A, Y is also present in set A. So Y is also 1, 2, 3, 4, 5, 6 up to 14. Is it possible that Y is 0? Is it possible that Y is 0? What is Y? Y is an element which is present in set A. 0 is there in set A? No. Whatever X is present in set A. Y is also present in set A. R is a relation on set A means R is a relation from A to A. Okay. Now I am going to write this relation in, see here the elements, the order pair x comma y satisfying this equation. They given this relation like this. They given that 3x minus y equal to 0. From this, what is y? You take minus y to this right hand side, what it will become plus y. Y equal to 3x, correct? So the same thing I written, y equal to 3x. In place of x, you take 1. In place of x, you take 1. You put x equal to 1 in this. Y equal to 3 into 1, that is 3. Here y, x both are there in set A. That you need to understand. X is also there in set A, y is also there in set A. 1 is there in set A? Yes. Is 3 is there in set A? 3 is there in set A? Yes, it is there. Now, in place of x, I'll take 2 because x is in set A. In place of x, I'll take 2. put here in this equation, in place of x you write 2, y equal to 3 into 2, that is 6. 6 is there in set A? Not there now. 6 is there in set A? Yes, it is there. 5, 6, 7, 8 up to 14 is there now. 6 is there in set A. Okay. So x is there in set A, y 6 that is also there in set A. Okay. Now you take x equal to 3. Okay. Take x equal to 3. Y equal to 3 into 3, 9. 9 is there in set A? Yes, it is there in set A. Now you take x equal to 4. X equal to 4. Y equal to, in place of x you write 4. 3 into 4, 12. 12 is there in set A? Yes. You take x equal to 5. 5 is there in set A? Yes, it is there. 5. Y equal to what? 3 into 5. 3 into 5 is 15. 15 is there in set A? No, does not belongs to set A. Try to understand this. If I take x is 6, 6 is there in set A? Yes. If I take x is 6, y is 18, but 18 is not in set A. Here, x value must present in set A, y value also must present in set A. If I take x equal to 7, y does not belongs to set A. Try to understand. Here x is in set A, y is also in set A. That's why I am not considering other elements. If I take x is 14, y is 3 into 14. 3 into 14 is present in this? No, it doesn't present in this. I hope you are understanding. So, what relation I got here? Order pair 1, 3. You see here 1, 3. X is 1. When x is 1, y is 3. Order pair, you see 1 is there in set A, 3 is also there in set A. Okay, now you can check when we substitute 1, 3 in this equation. In place of x you write 1, 3 into 1. 3 minus, in place of y you write 3. 3 minus 3 is 0. Satisfying? Okay, you see here when x is 2, y is 6. That means order pair 2, 6 is in this relation. Here this is in set A. This is also is there in set A. When I substitute 2, 6 in this equation, it must and should satisfy. X is 3, y is 9. X is 4, y is 12. 5, 15 doesn't belongs to this relation because 15 is not in set A. Even though 5, 15 satisfies this equation, 5, 15 satisfies this equation, but this 15 is not in set A. Here as per this, x must present in set A, y must present in set A. I hope you are understanding. You try to understand why I am explaining all these things in this much detail. What point I am discussing, all are important. Listen carefully, right? Right, what happened? They are given a relation. We need to check that relation is reflexive or symmetric or transitive. For that, I just written this relation into roster method. Here, whatever this part is there, green color part, you do it in the margin. No need to continue this in the question. It's a marginal work, rough work. You practice a side. In the margin, you practice these things, green color one. You just write the relation in roster method. Once we got the relation in roster method, now we can check reflexive, symmetric, transitive. Reflexive property we need to check. What is reflexive property? For any x belongs to set A, order pair x, x belongs to the relation, then that relation is reflexive. For any x belongs to set A, order pair x, x belongs to the relation, then that relation is reflexive relation. You see here, 1 is there in set A? Yes, 1 is there in set A. So you take 1 in set A. Order pair 1, 1 is there in the relation. Order pair 1, 1, you see this relation. In this relation, order pair 1, 1 is there. 1, 1 does not belong to the relation. So, what is the definition of reflexive relation? For any x belongs to A. For any x belongs to A, order pair x, x must present in the relation. Here if I take 1 is there in set A, but order pair 1, 1 is there in the relation? No. So we can say that R is not reflexive. Okay. Here one very important point. Suppose order pair 1, 1 is there in this relation. You suppose order pair 1, 1 is there in this relation. We cannot say that it is reflexive. You need to take second element 2. You need to take second element 2 in set A. You need to check order pair 2, 2 is there in the relation or not. See, when it is not reflexive, giving an example and saying that it is not reflexive is very easy. When it is reflexive, you have to be very careful and you should write answer very carefully. This is not verification method. In so many classworks, I saw in some other books, they'll write it wrongly. what I am trying to say, when it is not reflexive, you just identify the example, just counter example. You take one example which is not satisfying reflexive property. Because of this, we are saying it is not reflexive. You see here, 1 belongs to A. I am saying that order pair 1, 1 does not belongs to the R. That means this is a contradiction to that reflexive property. So that I am saying that's why R is not reflexive. This is not reflexive. I hope you are understanding what I am saying. In case you take 1 in set A, here 1, 1 is there. Suppose 1, 1 is there. You take 2 is there. Order pair 2, 2 is also there in this. Can we say it is reflexive? No, you cannot say it is reflexive. You need to check for every element in set A. What is reflexive property? For every x belongs to A, order pair x, x is there in the relation or not, that you need to check. However, what I am trying to explain, you just find out one example. When it is not reflexive, give an example, say that it is not reflexive. When it is reflexive, you have to be very careful. So I am saying total 9 bits are there in this first question. If you understand all 9 bits, it means you understand this full exercise, right? You see here. So R is not reflexive. Symmetric. What is symmetric property? If I take an order pair A, B in the relation, if order pair A, B in the relation, if order pair B, A is also present in the relation, then we say that relation is symmetric relation. First, you take order pair 1, 3. 1, 3 is there in the relation? Yes. Now you check 3, 1 is present in this relation or not. 3, 1 is there in this order pair 3, 1? No. Order pair 3, 1 does not belong to the relation. So as we consider A, B in the relation, B, A is not in the relation. That's why we say it is not symmetric. Listen carefully. 1, 3 is there. Suppose 3, 1 present in this. Suppose 3, 1 present here. Can we say this relation is symmetric? No. You need to check for every order pair. First you taken this. You checked for 3, 1. It is there. Okay. Next you go for order pair 2, 6. You need to check 6, 2 is there or not. Like that, for every order pair in this relation, you need to check B, A exist or not. I hope you are understanding. That's why I am saying when it is not reflexive, when it is not symmetric, writing answer is very easy. When it is reflexive, when it is symmetric, writing answer is not that much easy, right? See here, it is what happened here. I taken 1, 3. 3, 1 is there in this? No. Feel happy because you are able to identify that it is one example. You are able to identify one example which is not satisfying symmetric property. So I am saying R is not symmetric. This seems to be very simple, but as the number of problems increases, what points I am discussing, all the things comes to the matter. Now, transitive relation. What is transitive relation? In the given relation, you try to identify two order pairs A, B, B, C. In the given relation, you try to identify two order pairs A, B, A, B, B, C. A, B, it ends with B and it starts with B. See here, how to check the transitive property? Simple method I will say. You take first order pair 1, 3. It ends with 3 na? You check any other order pair which starts with 3. Here, yes, that means you are able to identify A, B, B, B. You look here, A, B, B, C. You are able to identify two order pairs which is satisfying the condition A, B, B, C. 1, 3, 3, 9. Okay, 1, 3, 3, 9. What is A, C? A, C means 1, 9. A, C means 1, 9, right? See, 1, 9 is there in this relation. 1, 9 does not belong to the relation. Therefore, R is not transitive. See, last class, 40 minutes video, reflexive relation, symmetric relation, transitive relation. Please go through that video first. Then only you watch this video. Otherwise, very confusing one. See here, 1, 3, 3, 9. Suppose 1, 9 is there in this. Suppose 1, 9 is there in this relation. Can I say it is transitive? No. Like that, you need to take any such other order pair. Suppose 2, 6. You need to search any other order pair which starts with 6. Like that, you need to search. Like that, you need to find out all possible order pairs A, B, B, C. Right? Okay. R is not transitive. What happened in this example? I'll I explained all the things in detail. Now quickly I'll revise this problem. See here, first thing, reflexive property or not. You know what are the elements present in set A. Set A is what? 1, 2, 3, 4, 5, 6, like that up to 14. You take 1 in set A. Order pair 1, 1 is there in this relation? No. So this is not reflexive. Over. You take first order pair 1, 3. 3, 1 is there in this relation? No. So R is not symmetric. Okay. Now transitive relation. You need to check an order pair. You need to check a pair of order pairs such that A comma B, B comma C. For that you take 1 comma 3, 3 comma 9 exist. A comma B, B comma C order pairs exist. You need to check for A comma C present in the relation or not. Order pair 1 comma 9 present in this relation or not. You need to check. Order pair 1 comma 9 does not belong to this relation. Therefore R is not transitive. What is this first bit? They given one relation. They are asking you to check reflexive, symmetric, transitive. It is not reflexive. It is not symmetric. It is not transitive. Now we'll move to the second bit. See, what is the second bit? Relation R in set n of natural numbers. This relation R is on set n. What is n of natural numbers? How the relation R is defined? Order pair x comma y such that y equal to x plus 5 and x is less than 4. They given that this relation is in which form? This relation is in set builder form. Okay, I said in last problem, 3 points important. First, what is the given set? R is a relation in set of natural numbers. Natural numbers, you know what are natural numbers? 1, 2, 3, 4 like that. It's an infinite set. Okay, and defined by. And second point, R is a relation in the set n. That means R is a relation from where to where? R is a relation from n to n. This you need to identify. These 3 points you need to write clearly. Third one, what is the given relation? R equal to order pair x comma y such that y equal to x plus 5 and x is less than 4. These 3 points are written. Now the thing is, I'll write this relation in roster method. This is in set builder method. If it is in roster method, it is very easy for us to decide reflexive, symmetric, transitive. Okay. So here x is what? X is less than 4. Here R is a relation from where to where? R is a relation from n to n. That means x is what? X is a natural number. What is y? Y is also natural number. X is natural number, y is natural number. But in the process of satisfying this equation, x value is less than 4. What are the natural numbers which are less than 4? What are the natural numbers which are less than 4? 1, 2, 3. Correct or not? 1, 2, 3. So in place of x I can take 1. In place of x I can take 2. In place of x I can take 3. In place of x can I take 0? 0 is less than 4 now. 0 is less than 4 now. In place of x can I take 0? No, because x is a natural number. 0 is not natural number. In place of x you cannot take 0. X can be taken 1, x can be taken 2, x can be taken as 3. Okay. Now in this equation, in place of x you write 1. In place of x you write 1. 1 plus 5 is 6. See, when I take x is 1, when I take x is 1, y is 6. I can take x 2 because 2 is a natural number and 2 is less than 4. In this, in place of x you write 2. In place of x you write 2. When I write x is 2, y is 7. See, 2 comma 7. X is 2, y is 7. You take x is 3. In place of x you write 3, x is 3, y is 8. I hope you understand. I can take x as 1, 2, 3 only. When I take x is 1, y is 6. When I take x is 2, y is 7. When I take x is 3, y is 8. You can check all these x values are natural numbers, and moreover here it's satisfying this condition. You can see these are the natural numbers. You have to make sure that x is a natural number, y is a natural number. What happened? They given a relation from n to n in set builder form. I written that relation in roster method. Now I need to check reflexive, symmetric, transitive. See, 1 is there in set n. Order pair 1 comma 1 is there in this relation? No. So R is not reflexive. When it is not, when you identify an example which is not satisfying reflexive property, writing this answer is very easy. Suppose 1 comma 1 is present in this relation. Can we say this relation is reflexive? No, you need to take the second element 2. You need to check 2 comma 2 is there in the relation or not. Like that, for every n, for every x belongs to n, order pair x comma x belongs to the relation or not, you need to check. However, when it is not reflexive, feel happy because writing answer is very easy. You take 1 in set n, order pair 1 comma 1 is not in the relation, therefore R is not reflexive. Symmetric property. What is symmetric property? You take an order pair A comma B in the relation. You check order pair B comma A is present in the relation or not. You take order pair 1 comma 6 in the relation. You 6 comma 1 is there in this relation. You check 6 comma 1 is there? Not there. So you identified an example which is not satisfying symmetric property. So we can say that it is not symmetric. When it is symmetric, suppose 1 comma 6 you taken, 6 comma 1 is present somewhere here. Can we conclude that it is symmetric? No, you cannot conclude. You need to take 2 comma 7, you need to check for 7 comma 2 is there. For every order pair A comma B in the given relation, you need to check B comma A is present in that relation or not. Okay, all these things you can understand only after doing all 9 bits. Okay, see, so we identified an example which is not satisfying symmetric property, therefore R is not symmetric. Now about transitive. What is transitive relation? You identify a pair of ordered pairs such that A comma B, B comma C. You see here 1 comma 6. 6 comma, is there any other order pair starts with 6? No. Okay, with this we are not finding A comma B, B comma C such type of order pair. Now you take this 2 comma 7. Is there any other order pair starts with 7? No. No. So we are unable to identify 2 comma 7, 7 comma something. Okay, no problem. With this also check. Now you come to this 3 comma 8. You are able to identify any other order pair which starts with 8? No. So you are unable to identify A comma B, B comma C. Then no need to check A comma C. If you are able to identify A comma B, B comma C in the given relation, we will check A comma C is present in the relation or not. If A comma C present in the relation, then we say it is transitive. If A comma C does not belong to the relation, then we say it is not transitive. First of all, you are unable to identify A comma B, B comma C in the given relation. How you will check for A comma C? We cannot check. I hope you are understanding. So you are unable to identify A comma B, B comma C in this relation, then no need to check A comma C. That's why simply we say that this relation is transitive. See, to understand this class, last class is very, very important. Please check the last class first, then only come to this. If you understand last class and in first problem total 9 bits are there, if you understand all these 9 bits, then these are very easy. Third bit. A relation R in set A defined like this. Here you need to understand 3 things. First is what is the set A. Second thing, what is the relation? Relation R in the set A. That means R is a relation from A to A. How the relation is defined. Like this relation is defined. So as usual, I'll write 3 steps. First, given set 1, 2, 3, 4, 5, 6. Next, relation from A to A. Next, given relation order pair x comma y such that which order pair y is divisible by x. Okay, here writing this relation in roster method, we need to do? We need to check this relation is reflexive or symmetric or transitive. First 2 examples, what I said, writing this relation in roster form so that we can easily check they are reflexive or symmetric or transitive because you are in the beginning. No need to write this relation like this in roster form. By seeing this, by keeping roster form in mind, you can do this problem. Without writing this relation in roster form also you can do this. Writing this relation in roster form takes time. However, this is the smaller bit. In case if this set A is infinite set, how you will write this relation in roster form? This is very difficult. Try to understand what I am saying. Okay, here what you need to know, x is there in set A, y is also there in set A. X is in set A, y is also there in set A. That means x can be taken as 1, 2, 3, 4, 5, 6, y can be taken as 1, 2, 3, 4, 5, 6, right? Now, how you will get this order pair? It is a subset of A cross A. A cross A. A cross A. You just take pen paper and calculate A cross A first. A cross A contains 36 elements. First order pair 1 comma 1. Next 1 comma 2, 1 comma 3, 1 comma 4. A cross A I am saying 1 comma 5, 1 comma 6. Next 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. Next 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6, like that. 4 comma 1, like that. Total 36 order pairs will come. No need to write all those things here. First thing, which order pair belongs to this relation? Y is divisible by x. Suppose 1 comma 1, in A cross A, 1 comma 1 is the first element. 1 is divisible by 1. Of course 1 is divisible by 1. So 1 is divisible by 1, order pair 1 comma 1 belongs to this relation. Now in A cross A, what is the second element? Order pair 1 comma 2. Try to understand please. Second element in A cross A, 1 comma 2. 1 comma 2. 1 comma 2 is 2 is divisible by 1. 2 is divisible by 1. You write 2 and divide with 1. Is 2 is divisible by 1? Yes, 2 is divisible by 1. So order pair 1 comma 2 belongs to this relation. Now 1 comma 3. 1 comma 3. 3 is divisible by 1? Yes. Similarly 1 comma 4, 1 comma 5, 1 comma 6. Now next order pair in A cross A, 2 comma 1. 2 comma 1 is 1 is divisible by 2. Take 1 and divide with 2. Is 1 is divisible by 2? No. So the order pair 2 comma 1 does not belongs to this relation. Next order pair in A cross A, that is 2 comma 2. 2 comma 2 is 2 is divisible by 2? Yes. Like that. 2 comma 3 is 3 is divisible by 2? No. Next 2 comma 4 is 4 is divisible by 2? Yes. That's why I written here. 2 comma 5 is 5 is divisible by 2? No. That's why not written here. Next 2 comma 6 is 6 is divisible by 2? Yes. That's why written here. Next 3 comma 1. No, not written. 3 comma 2. No. 3 comma 3 is 3 is divisible by 3? Yes. 3 comma 6, 4 comma 4, 5 comma 5, 6 comma 6. All these things I considered from A cross A. I cannot write A cross A here. In exam you also don't write A cross A. By keeping that A cross A in mind, you can write this easily. Okay. However, this problem can be done without writing this relation in roster method. Right. Good. First thing, however, I written this relation in a roster method. Now I need to check reflexive property. You take 1 in set A. Order pair 1 comma 1 is there in this relation? Yes, it is there in this relation. You take 2 in set A. 2 is there in set A. Order pair 2 comma 2 is there in this relation? Yes, here it is. You take 3 in set A. Order pair 3 comma 3 is there in this relation? Yes, it is there. You take 4 in set A. 4 in set A. Order pair 4 comma 4 is there in this relation? Yes. You take 5 in set A. 5 is there in set A. Order pair 5 comma 5 is there in this relation. You take 6 in set A. Order pair 6 comma 6 is there in this relation. What it tells? It tells that for every x belongs to set A, order pair x comma x belongs to the relation. Therefore, this relation R is reflexive. Therefore, this relation R is reflexive relation. Now, symmetric. This relation is symmetric or not. You take an order pair 1 comma 2. You take an order pair 1 comma 2. 2 comma 1 is there. You check. 2 comma 1 is there. No. 2 comma 1 does not belongs to this relation. So, for if I take A comma B, you take any of such order pair. Suppose you take 1 comma 3. 3 comma 1 is also not there in this. Like that, I identified 1 comma 2. 2 comma 1 does not belongs to this relation. Therefore, this relation R is not symmetric. Right? Now, transitive relation. Actually, checking transitive property takes so much of time in regular method. I'll explain this in theory method so that I want you to understand transitive property. What is transitive property? First, you take A comma B, B comma C. A comma B, B comma C in the given relation. Suppose there exists A comma B, B comma C in the given relation. When A comma B belongs to R, when B is divisible by A. Correct? See here, what is the relation? How the relation is defined? Order pair x comma y such that y is divisible by x. See, order pair A comma B belongs to R. B is divisible by A. Order pair A comma B belongs to R means B is divisible by A. Order pair B comma C belongs to R means C is divisible by B. C is divisible by B. If B is divisible by A, if B is divisible by A, B can be written as multiple of A into some integer I written. K1 is some integer. If B is divisible by A, B can be written as A into some integer. Here C is divisible by B means C can be written as B into some integer. Okay, what I am trying to say? I am trying to say A comma C belongs to R or not. When A comma C belongs to R, when C is divisible by A. When A comma C belongs to R, when C is divisible by A. So as I taken A comma B belongs to R, I got that B is A into some integer. As B comma C belongs to R, I can write C as B into some integer. Now you see here C equal to B into some integer. Now in place of B is, look here, in place of B I can write A K1. So in place of B I written A K1 into K2. Here K1 into K2. K1 is an integer, K2 an integer. K1 into K2 is some integer. A into K3. What I got here? C equal to A into K3. That means it tells that C is a multiple of A. If C is a multiple of A, then C is divisible by A. C equal to A K3. That means C is divisible by A. If C is divisible by A, the order pair A comma C belongs to R. I said no. When it is reflexive, when it is symmetric, when it is transitive, you have to write the answer very carefully. Therefore, this relation is transitive relation.